Hello, my name is Zechariah Servin. I will be going over Group 9's code demonstration. So this code demonstration follows question 53 in the textbook along with the text on pages 794 to 796. This code follows the RSA application that will encrypt and decrypt a message input by a user. To start off with this code, you set up a scanner that I have named scanner, and this will allow the user to input their desired values when prompted to do so. These are going to be the rest of the variables that I have used in this presentation. I tried to keep the naming conventions very similar to the ones in the textbook in case if someone wants to go back and look through the textbook along with this code, it should help you make the correlations to what the text also says. So to start off, the code asks the user to enter in 3 prime numbers, the first one being called prime P, next prime Q, and then the value D. These all will be prime numbers like I said. Next, based on the values that were inputted by the user, it's going to compute the values of int n and int z. These are both based off of prime P and prime Q, the first 2 prime numbers inputted by the user. Then the value of E is going to be determined, and this is determined by the rule that calculates E such that E times D equals 1 mod Z. I just rewrote that if you divide D by both sides, that's what this would be right here. So in the start, the original message portion, this is going to ask the user to enter a message. So the message will be a scanner that reads in a line, and then it's going to call the message switch method that takes in 2 parameters, message and message values. This is the method right here. This function will take in the original message and it will assign each letter of the message to its corresponding alphabetical position, and that then will be stored into an array list called message values. As you can see, if the message has an A in it, that will be 1, so forth all the way down to what Z would be at 26, and then I have a -1 as space. So then from here, you would then go to the encryption portion of the code, and this will call the encryption process method, and that is right here. That takes in 4 parameters, message values, into E, into N, and then another array list of encryption. That encryption will store all of the encryption values that will be calculated right here. And this for loop will run for the exact size of the message values, or well, would be the exact size, just one less, because I starts off at 0. And to calculate the encryption value, you're going to put the current iteration message value to the power of E and then mod n all of that, and that will calculate the encryption value. And then you're going to add that to your array list, and you will print out the value so that the user can see that their value did change in fact and it became encrypted. Then from that, we will do the decryption portion. That goes with the decryption process method, the decrypted message switch method, along with the print description, or not description, the print decryption method. So to start is the decryption process. This is the reverse of the encryption process. So this runs for the size of the encryption array list, and this does the decryption value is the encryption current iteration index to the power of D, then mod and that, and then you would add that value to your decryption value, your decryption array list. And then from there, it's going to be the decrypted message switch statement, which is going to be the opposite of the original message switch statement. So this, you will be getting integers as your values. So if the at index 0. If it is a 1, it would be A, would be your decrypted message. But let's say your original first value was S, this value would be SS1. I will show you what that will look like through the print decryption. So this will print out every single value that was stored in the decrypted message array list. So from here, to start this, you can either click here and you can click the run project button, or as you can see there, the F6 button will also run this project. So I'm going to do this, enter a prime number, that is going to be up here, enter a prime number. I'm going to do 3. Another prime number is 11. One last is a 7. My message that I'm going to use is Susan, just like that was in the textbook. So you can see the encrypted message is going to be 28, 21, 21, 5, 5, 26. To the normal person, it's going to be very difficult for them to figure out what that is. And the decrypted message is Susan, just like the original message. You can also rerun this, and you could do the same. We'll do the same values, and then we could do hello class, and you could see it all correlates. The double L's are going to be the 12s, and then you can see that is corresponding to here, and then it's the hello class. That is my portion of this project. Thank you so much.